So, I'm Nicolai, Java developer advocate at Oracle, and today it's going to be you, me, and from idea to IDE, how Java features are considered, designed, and shipped. Who of you have used this feature? Nice. Wow, that's very good. Okay, text blocks. So what does it make a feature though? I mean, it compiles now, it didn't compile earlier. What changed? It was added in Java 15, right? And a text block is a multi-line string literal that avoids the need for most escape sequences, automatically formats the string in a predictable way, and gives the developer control over the format when desired. It was not only a language change, there were also a few changes in APIs. And this is what makes up at least part of a feature. You're not supposed to read this. It's not going to be on the test. That's an excerpt from the Java language specification, the JLS. And the JLS specifies the behavior of the Java language. And if you're an architect, you're done now. It's a specification, nothing else needs to be done, right? There are even more specifications than just this one. The one that I showed you is, where's my cursor? There it is. Oh, the delay is massive. That was language NVM. Down here. There you go. And then we have API and documentation. There's the specification for the tools. There's lots more. Again, that's just specification though. If you're a developer, you know that you also need code backing that specification, that requirement, actually implementing it. And that's the other half of the truth. The one is the Java language specification or the other specifications. And the other half is OpenJDK, the project that develops the JDK repository. You can see that on github.com/openjdk/JDK. That's what this is about. So when a feature is done, it comes as syntax or VM capabilities, as APIs. And as I just mentioned, it is specified in those documentations and implemented in OpenJDK. It fulfills these requirements and it fits seamlessly, ideally, into the entire language and into tool support. The best case scenario is you look at a new feature and you're like, why did this take so long? This is so obvious. That's when it works well. When you're looking at a feature and you're thinking, oh, this is very, very complicated. How do I even use this? That's why it took them so long. Then the guys who developed this made a mistake. Ideally, they all fit in perfectly and work well. But how do we get there? How do we get to the point where a feature like text blocks or lambdas or the module system or all the other changes we've seen make it into the language in such a seamless way? It starts, as usual, with an idea. From there's an exploration phase where different ideas are vetted. We get prototypes, specific proposals, reviews, and then eventually we get the feature. And that is what we're going to talk about today. We just start at the bottom, finalized feature, and now we're going to go upwards, and we're going to talk through each of these steps, and you will see as we go that they become more vague and probably more unknown to you with each additional step. So let's go into previews. Java 21 is chock full of them. Foreign function memory APIs in its third review, and they have a bunch of things that review for the first time. The bottom two, scope values and structure concurrency, are also APIs, and they were incubating before, which is a phase that sees even more change than preview features. But the other three are language features: string templates, simplified main, unnamed patterns and variables. Those are preview language features that are currently being explored. And the concept of a preview feature is itself specified. There's a JAP 12, and then there's a JAP draft that overhauls this a bit. And it's also specified in the Java language specification. So this is the part of the Java language specification that describes how a preview feature works, right? So again, this is not just something that somebody sneaks into the JDK. It is itself a specified step. And there are requirements for what goes into a preview feature. We saw the specification and the implementation before, and those are present here as well. So they need to be specified in the JLS, or preview features are mentioned explicitly, and then there is a diff of the JLS that this preview will bring once it's actually finalized. And on the implementation side, the implementation is present, but it's disabled by default, both at compile time and runtime. This is what that looks like on the specification side. You can see in the top left, this is for Java 14, when text blocks were still in preview, so they're mentioned here, text blocks. And then this is the diff. You can see that this is going to be added, the green stuff, and then there's some red lines, so like here, things that will get eventually removed when this change is enacted, right? So it's mostly additions, which makes sense because text blocks largely just adds a new thing to the language, so that needs to be specified. When it comes to the implementation, and as I said, it's disabled by default, you need to disable it explicitly. For compile time and runtime with enable preview, you get a compiler warning, and it pins the Java versions. I'm going to show you all that, and then we're going to discuss why this is necessary. So we're taking this class, I'm trying to compile it with Java 15. With Java 14. In 15 it's final. I try to compile it with Java 14. So the compiler spots what's going on. It says text blocks are a preview feature, so it spotted the text block, but it says it's disabled by default. And I need to use enable preview to enable the text block. So on the next line I go Java C enable preview, and if I do just that I get another error. I need to mention the Java version. Okay, so I try it again. Java C enable preview release 14, and now it works. The compilation goes through, but I do get a warning. I do get pointed out to me that this is a preview feature. If I now try to run this with Java 14, again it doesn't work. It tells me it's an unsupported class version error. Preview features are not enabled for text blocks. So again, it notices that I'm using preview features and wants me to unlock them explicitly with enable preview. And now you might think, well, on 15 it's final, right? And didn't actually change between 14 and 15. So surely I can run this code on 15. That's even worse, because you just can't. Text blocks was compiled with preview features that are unsupported. There you go. This version of the Java runtime only recognizes preview features for class file version. That essentially means the Java 15 runtime only recognizes preview features that are preview in 15. So what I did here by compiling with enable preview in 14, I forced everybody to run this on 14 with the enable preview flag. And that's intentional, because these features are a preview so that they can be experimented with, that people can try them out, but they are not there to be shared around, right? Because they might still change. So if I develop a library, I should not ship a library that uses preview features. But if I do, it's paramount that my users are aware of that and don't just start using my library and then it breaks on the next version. So that's why these hurdles were put into place to prevent to prevent the accidental use in production. But also, if it's out there, IDEs can prepare for that. Already mentioned that you can experiment with it and report feedback. And the considerations of this phase, of the phase before a final feature is this feature surfaced correctly? You can see that it's not a very large consideration, right? Whatever else you need for a feature, like requirements, an idea, and the implementation at the core, that's already there. The question here is the functionality surfaced correctly so you can use it in a way that is as seamless as we want it to be? You know, and even though the OpenJDK community applies this within the JDK and makes corpus searches and looks how this fits into other existing projects, there can always be unforeseen edge cases, right? This is never large enough to cover all possible cases, and that's why it's important that we in the community experiment with these features to tell the developers behind this, well, you know, there was an unforeseen edge case here, something that you might want to work on. Preview features evolve a bit, but mostly on the surface. So my guesstimate is that within 1 to 2 years, the rate of change is maybe 5%, and then they're done. That 5% is really a guess. How do you measure how much of a feature changed, right? And how many of the preview features make it into final? Well, if we just count them up, it's actually all of them. But I don't want to overpromise, so I deducted 5% for the possibility that preview features might not make it. We had one almost example with raw string littles in Java 12, which eventually became text blocks. They were never formally a preview, but they were very close. They were already, the pull request was open, everything was ready to go, and then very late the decision was made to pull them. So, you know, it's not 100% progression, but many of them. By the time you see a preview feature, it's very late, and it's already very mature, and you're very likely going to see that feature with minimal changes. But you can never rely on that 100%, right? So what's before the preview phase? What's before the phase where we can actually use these features in practice? Yes, probably not in production though. But what's before? That's the proposal phase. So if we look at JDK enhancement proposals, those are the ones that are currently being worked on. There are more, of course. I just picked a few examples. There's an asynchronous stack trace VM API. We will probably be able to put statements before the super call or the this call in a constructor. And there is JEP 450 that makes object headers smaller for less memory consumption of your heap. You know, stuff like that is being worked on. They're all JEPs. Now, how do you define how a JEP works? Well, it's easy to define a JEP. You just write a JEP, right? And that's actually the case. So there's a JEP number 1 that defines how JEPs work. And there's a JEP 2.0 draft, which is just a draft. I'm not sure why, like it's a bit weird. Don't ask me. But anyway, most of that is explained in the second one. And that contains this funny graph. Okay, you got that, right? Okay, no kidding. It's not terribly important that you get all the details. The green parts are roles, not rules, roles. Who can do what? Not that important. Then we have the grayish lines that go to closed withdrawn and to propose to drop. Those are evil states. We don't want those, right? The main thing is a diagonal. You see a JEP draft, and then it goes through these steps, and eventually it's closed and delivered. If you want to see what JEP is in what state right now, you can go to these links. The slides are online, and I will also show you a link later, and you can see them on slides.nipafx.dev. So if you follow up on this, these are links to the JBS, the Java bug system, which is basically just Jira, but slower. And sometimes I get the joke, like even slower. I don't want to harp on Jira too much, but it feels very slow. Anyway, so a JEP is just a bug, an issue, with a specific marker. And I filtered by those markers so you can see what JEPs are in what state right now. And I went through the hard work of counting this for you. At the moment, we had 437 drafted JEPs. Draft is the earliest stage, right? So 437 have been drafted, and then most of them, went beyond. 51 are still in draft, and then we have 46 that are candidates, and some of them have not been changed for 3 years, so I classified them as dormant. So 33 are somewhat actively development on. And we had a bunch that were closed, right? 18 were withdrawn, 31 were rejected, and 291 were delivered. So that's a pretty big chunk of those, right? This is what this looks like in the graph. So we have 437 in total, and then we have this huge span, the progression that they're supposed to go through. 46 are somewhere on that progression, 291 were delivered, and then we have a few still in draft and a few closed, withdrawn, or rejected. So that's like, withdrawn feels like I'm leaving, and rejected is like you're fired. If we just look at those JEPs that were actually closed, and then count those. So all of those that were closed, all 340 were clearly drafted at first, right? And then 18 withdrawn, 31 rejected, and 291 delivered. We saw those numbers, but that adds up to 85% having made it. So of every JEP that was ever drafted and eventually closed, 85% of those made it, which is still a pretty high rate, right? This is clearly not a phase where just things are thrown at the wall to see what sticks. This is already a step in the process where there's a good idea of what's going on. The JEP is just the specification part. There's also an implementation part, as usual. And this one is, for larger projects, it might just be a full fork, like Valhalla, All the Valhalla JEPs live in there in this one fork. Amber has more focused JEPs, smaller ones, they often get away with the branch within the fork. So OpenJDK Amber is the fork for the project Amber JEPs, and then super init is the branch for the statements before super. So at the same time as the JEPs are being written and progress through their stages, implementation is developed that lives here in OpenJDK. So the goals of these JEPs is to expose the proposal to a wider audience and to document how it got there. Again, at this stage, it's somewhat mature, right? At the bottom, the question is this the right way to do it? So it's already decided that this should probably be done and what the problem was. The goal here is to seek feedback on the proposed solution so that you can read through that and think what that would mean for your code base. Would that work? What changes might have to be made? And as I said, to motivate, describe, and archive it so that you can later track these decisions down and see why they were made the way they were made. JEPs, I should probably mention earlier, put that even on the slides. JEPs did not start together with Java. They do not cover the whole development time of Java. They started being used, I think, in the early 10s, but really over the last 5 years where they made the main development vehicle, where everything becomes a JEP. So we cannot go back in time to the beginning of Java and track every decision like this, which is a bit sad because they're really well written and they're really a treasure trove of information about all these features. So the proposals evolve noticeably, particularly until the candidate phase. So this very early stage, in the draft stage, a lot of changes are happening. But most of them are eventually delivered. And if you look over the JEPs and see how long they lived, some of them happen really fast, some of them take forever, but most of them can be boxed into this half a year to 3 year time box. Most of them are done during that time. They do change a lot, specifically during the draft stage. There's a lot of churn in those JEPs. Some of them are rewritten entirely. Some of them just see a little bit of change, so average it out at slightly below half. And as we've counted, 85% progress. So let's go one step back further. And if you follow Java development closely, you probably somewhat knew about the first 3 steps. Now we get into the space that is less well known, and frankly, it's much harder to track. There are some ongoing explorations. Records might get withers. So on regular Java objects, on a bean, you might have a setter, which I don't think is a very good pattern, but you know, they're very common. A setter sets the value of that field. But records have immutable fields. You cannot reassign them. So what do you do there? Well, the common approach in function programming is to have a with method that you would call and say, I give you this object, or I call on this object, and I say person with name John Doe, and then I get back a person that is exactly like the other person, but has a name John Doe. Just like setters, you can write all of those or generate those. And just like setters, that's really lame work, and it feels very unnecessary. It feels like you're, beating on the language to just do the simple thing you want. And we might become lucky, and we have a situation where records have a so-called with expression or with construct, which is in the language, where you might be able to write person, which must be a record, person with name equals John Doe. And that would be pretty cool, because then records could do that automatically without you having to write these withers. They have a few other advantages as well. So there's a design note on that. We might get declared patterns, whatever those are. There's a long email thread on that. And Project Leiden is working on shifting and constraining computation. Again, not going to go into any details. There's a white paper on that. So the artifacts here are much more widespread, much more different formats. There are mailing list and changes. If those go well, there are often meetings, sometimes at conferences like these. Design notes as the ones I just linked. There are often prototypes being developed in these forks, often in forks private to the people working on these proposals. Sometimes you see conference talks on this. On the module system, for example, there were a bunch of very interesting talks in the early phases. Brian Getz likes to do this. There are a bunch of crazy talks about Valhalla where he dives very deep into the various prototypes way before the feature shipped, obviously, because it's still not out there. And eventually they might make it a JBS issue. And even though this order is not definitive, it's like a rough, trajectory that these are taking. But unlike the steps so far, this one is mostly unspecified, mostly unstructured, and without much barrier for contribution. I cannot create a JAP. I'm not a member of OpenJDK, and even if I were, you need to be like a special member of OpenJDK to just create a JAP. Or rather, you can draft whatever you want, but you still have to need agreement by somebody else to make it actual candidate JAP. But this, everybody can do, right? Everybody can just write an email to a mailing list and say, hey, I have this great idea. And so everybody does. So if you have an idea, don't just sit down and write to the mailing list. Maybe start a step earlier with the idea phase that we come to later. But the goals of this phase are to access feasibility and to shape a general idea about something that might be necessary to do into an actual proposal. Not to file off all the rough edges, that comes later, but to at least give it like an outline, give it a shape that can be specifically discussed. And also to estimate the complexity and the effort. Because if this feature is kind of nice to have and like an incremental improvement, but requires the entire OpenJDK community to drop and work on this for 5 years, it's not going to happen, clearly, right? So there must be it must be worth the bang for the buck. And the considerations here are also a little bit more vague and more like there are no bad ideas here, kinda. So does it fit into Java and the ecosystem? Can it be implemented? And then if it can be implemented, it fits, can it be introduced? So that's not always the case, right? There might be features that are great to have, and that might not even be terribly complicated to implement. For example, null-safe types, meaning, or null-aware types, right? The types where you write a type name like string, and you write string ? To indicate this could be null. That change is very feasible to make within the Java compiler. But can it be introduced? Is there a path from where we are to a path where that feature unfolds its full potential? And sometimes there's not, like with this one. This is very questionable whether we can go that path. But even if all of those are answered positively, what priority does it have? Some features are just good. They can be implemented, they can be introduced, something like text blocks maybe, but they never bubble up enough to become important enough to be worked on. And that's really something that Project Amber specifically tackles, is to sidestep all these large feature development projects like Valhalla, like Lambda, like Jigsaw, and focus on more on these small projects. If you want to learn more about Project Amber, by the way, I give a talk at 3, where I go into exactly that, all the small things that Project Amber did there. So, during exploration, features evolve fundamentally and many are dropped. My guesstimates is that this takes anywhere between half a year and half a decade. The rate of change can be substantial. How do you get more than 100% rate of change? You just rewrite something again and again and again, and that very much happens. So in this phase, there's a huge churn in there. Some features, specifically in Lambda, pop up quite late, and because they're not terribly complex, they're well thought out, and then they eventually land without too many changes. But that's not the norm. I think the norm is really like several rewrites of this idea. And the rate of progression is impossible to measure. So this is a guess between 1 quarter and 3 quarters, which clearly is, it's a big span, right? So really just guessing here. And the phase before that are ideas. Who did not do this once, right? At least once. You're working on something, it's frustrating, and like, oh my God, if Java had this feature, I'd be done. And it's like an hour later and you realize, oh crap, I didn't keep working though. Even more, this is what happens, right? I work on Java, I work on JavaScript. Why does Java have this cool JavaScript feature, right? Like, just get rid of the semicolons. Give me, I don't know, what other thing does JavaScript has that I like? I don't know. No, actually JavaScript, for small project, I actually kind of like it. Anyway, right, that's a common thing as well, right? It's probably more common with Scala, Kotlin, Groovy developers because they're also working on the JVM. hardly anybody ever comes over from Haskell and then keeps nagging on Java until it turns into Haskell. But yeah, it's a common question. It's a common way to have ideas. Even Brian Götz, who's working on this, has a lot of ideas, right? He has notebooks, actual photo of his actual notebooks, I asked him. So he needs notebooks to keep track of all of his ideas, right? And the reason for that is ideas are cheap. You don't need specification, you don't need a process, there are no barriers. You don't even have to pay attention to them. You can just write it down and just send an email and forget it. The important part is the execution, the part that comes after. So if you do have an idea and you think something should happen in that space, I can give you a tip. The best way to start this conversation on the mailing list is not go there with an idea, which is basically a proposal for an implementation. Go there with a description of your problem. What is the issue that you're having? What does it look like for you? Have you already asked other people, or have you looked into other projects, other open source projects, or other projects you worked in the past? What impact would it have there? Like, what's the issue there? What does it look like there? And then try to start with a problem statement and just allude to a possible implementation. You will get much better results there. So the goals here are to make Java and the JVM better, and the consideration is just, is this a good idea? Is it a good idea for Java? And is it a good idea now or in the future? Because sometimes it does make sense to wait for another feature to fall into place before doing this. Or maybe it's a good idea now, but with that upcoming change, it becomes obsolete, so let's not do it after all. So for example, let's rewrite all Java I/O APIs as asynchronous APIs. Many of them are actually, but you get my point. You know, rewrite something to all async. That could make sense potentially, but now we're hoping that virtual threads are going to make that unnecessary. So now would not have been a good time to propose that or to implement that. You know, maybe in 5 years, in case it turns out that, you know, Loom cannot do all the heavy lifting after all, you know, maybe then we're back to having more async APIs. I doubt it, but it's definitely possible. Now, if you want to guess on what these numbers that I mentioned earlier are, it's impossible. It's like, it's just, there's no way to track these ideas. They're not even, you know, they're not even necessarily discussed, right? If you talk to somebody at the water cooler about your idea that you had for Java, I can measure that. Which brings us to the last point, which I kind of cheated into there. It wasn't there before, and technically it belongs to the top. So we now talked about how ideas turn to explorations, into proposals, previews, and features, but even final features aren't final. Not really, right? You've all seen this for the documents you send around where somebody starts to attach final 2. It's like, what happened to final 1? It's like, anyway, so these do change, right? Very rarely, but they do. So when there are Java features, the question is, does it hurt? Is it used? Can it be extended or improved? And how much work does it cause if you can remove it or if you do change it? And if all of those questions are answered just right, things do actually change. So for example, the single underscore used to be a viable variable name up until Java 7, was deprecated for removal in Java 8, although the terminology didn't exist back then, it was deprecated in 8. It was made illegal in 9. So single underscore, you cannot use that as a variable name since Java 9, because we can now use it in Java 21 actually as a preview for unnamed variables and unnamed patterns. So the consideration here was, it's very rarely used, it's very easy to fix, and there's high value if we get this underscore back under control of the language. Concurrent mark sweep was removed. RMI activation was removed. And so there are different considerations here. Other things that are deprecated for removal, and this is not the full list, are primitive wrapper constructors, applet API, finalization. All of those will go eventually, and there's always, it's very specific and not complicated, but a lengthy consideration of whether this should actually be removed. Finalization is a good example. It is kind of deeply embedded into the language, right? You have this finalize method, everybody can implement that. There might be a lot of code out there that depends on this, but at the same time, it's very error prone. It causes a lot of headaches. It prevents performance improvements. Better mechanisms exist. It just holds Java back. It holds Java, the platform, back, and holds us back if we keep using it. So it needs to go. If you want to know more about this, I made a Inside Java newscast on the Java YouTube channel. That is me, although also looks like my dad. That's what David did for a thumbnail there. And then we talk about all the finalizations, all the deprecations that are currently ongoing. I can recommend for you to check that out to see what you should do to make sure that your code base, keeps working well once you upgrade to Java versions. Features are extremely stable. You could probably compute a rate of change by somehow smartly diffing the Java language specification, but I was way too lazy for that. So I just guessed. And also the survival rate. If you want to collect better numbers, be my guest. What I'm going for here is almost nothing changes. Always everything stays. That's Java's backwards compatibility, but it's not 0 and 100. Because that would be way too stiff and that would prevent useful and necessary evolution of the language. If anything, you could probably argue that these numbers should be, more rate of change and less survival rate, but that risks the one thing that was always very important to Java, which was protecting your investment, the time and money and resources you poured into creating the code that you have. So anything that touches that investment and makes it necessary to reinvest or to abandon is very carefully considered. Okay, so let's go with the full journey because I'm pretty sure you didn't get everything. So let's rewind. Let's start at the first step of an idea and let's go through this step by step. When you have an idea, the question is, can this be good for Java? And if you decide yes, and that it's somewhat, like it looks like it could be feasible, you go into an exploration phase where you try to figure out, is it feasible? How could this be implemented or introduced? And this is where you probably start prototyping, where you have discussion with other people, where you're going to figure out whether it makes sense to invest the time necessary to eventually make it a specific proposal. Is this the best way to implement the feature within the VM, within the compiler? Is this the functionality that you need to cover the requirements, to fulfill that use case? This is where most of us first hear about a feature, and then a preview is when we can actually start using it. Again, probably not in production, but you can use it in, in hobby projects, maybe in test code bases. My rule of thumb is with preview features, don't write more code that you're willing to rewrite when you make a Java update. So that's probably not a lot you want to rewrite, right? So usually it's like maybe a day's work or 2 days work. I think that would be fine. Is it surfaced correctly is the question there. Is the way that we use this feature done right? And once it's a feature, this should be like really small font. Because like basically nobody asked that question. Nobody likes to give stuff up, right? Yes, applets need to go, except for those like 3 projects that still use applets, right? So there's always somebody using someone. And that's, that sucks for them. Like nobody wants to redo that work, but again, it has to be balanced with the overall platform evolution. This is my effort to put everything that I told you into a table. So this is the one thing that you could take away from the talk, although you need to know what all these emojis mean. So during the idea phase, it's basically just notes and conversation that are artifacts, and then you can see how this slowly progresses towards something that is firmer and also it's self-specified, right? In the proposal phase, you have JEP1, which specifies which artifacts specifically you need. And the rate of change on the right-hand side drops to, well, it should be like 99.9 down there. So you can see the rate of change to the second to right column. This column, the rate of change, that drops to almost 0. And this is the rate of progression, how many features make it to the next phase, and that goes up. Okay, so one little detail I need to add at this point. I did not talk specifically about incubating APIs. If you want to put them into this discussion and this classification, they do not belong to preview, they belong to the proposal phase. They see much more churn than preview features. They are harder to use than preview features, so definitely go there. And they do come with alpha, beta style implementations. Previews are basically final. We're just waiting for review. In the past, these would have been final features. So they are done, but now we have the chance to get your feedback for another 6 or 12 months. but they're not like beta versions, but these like what the proposals, what the incubating APIs are about. I also focused on JEPs. Not everything is a JEP. API additions that are being made, there are just regular issues, right? Regular JBS issues, and they also don't follow this formal process. So those are, they do have a similar process, and they do end up as specified, but like it's not laid out like that, right? There is no formal process defined in a JEP for how a minor issue gets resolved. And so as a kind of closing thoughts, I want to discuss why that's so important. Why is it so complicated, right? Why can we not just have an idea and discuss an implementation and then implement that and have all of that take, I don't know, a couple months maybe? Like it is ideally well, ideally it's even faster in fast-moving projects. But why can we not have something moving something at that speed in the OpenJDK? And the answer is, there are millions of developers and billions lines of code out there. And it's not just one space where Java is used, right? It's used in industry to run anything from banking to actually industrial machines, or at least that's probably low-levelly written in C, but at least on the layer on top of that, logistics, for example, medical equipment. There's so much stuff in the industry section, but there's also research that is done with it. Games are written in Java and not just Minecraft. Many hobby projects are out there. And naturally, all of those different spaces have different needs for Java. And so it's very important to take all of that into account. And that also means that most of us will only see a shard of that, right? Maybe I'm working in banking. I know what Java in banking needs, what those requirements are, what would make Java better in that space. But that's just one sliver of the space. It's also the sliver that's on Java 6. So, you know, just get to 17, then we can talk. But so the point is, the OpenJDK community needs to take all of this into account as well as possible. And in the end, Java drives billions of euros of annual revenue, and you don't easily risk that for no good reason. So it's better safe than sorry. And that was it. Thank you very much for your attention. So as I mentioned, I'm Nicolai. I'm NipaFX online everywhere, including on Twitter, for example, you can find me. But more importantly, I do work for Oracle. I do work for the Java development advocacy team, and we do stuff online as well. You can go to youtube.com/Java to see me and my colleagues talk into a camera there. And if this kind of stuff is interesting to you, how Java is evolving, go to insight.java. It's an aggregator of interesting JEPs being posted, interesting email conversations, good articles on what is happening in Java right now and what will be available soon. So if that interests you, definitely go there. If you have any questions, I think I can take them now. We have a little time left over. If you yell loudly enough, I can answer your questions. Other than that, you can always find me around the conference today. I won't be there after tomorrow. Sorry, after today, maybe tomorrow early in the morning. So you can ask now or later if you find me. Do you have any questions? I take that as a positive. Okay, anyway, right. Find me otherwise, and I wish you a great conference. Have fun.